Ready.
All right. This is simulating a multi-spindle machine. We can also use it on single spindle machines where we're checking ODs on the fly. We're checking for short feed outs and part length on the fly, as well as checking in position. If you have a CNC machine, you could come in onto the end of a part and you could come in from a cross slide and check the diameter. We also have pneumatic broken tool detectors. Go, no go. If the tool is broken right before an expensive tap, shut your machine down right away. We also have an electronic broken tool detector. This unit knows its starting position, it knows the tool position, and can check in two directions. So it can look for chips on the tool, it can look for tool presence, and it can also make sure it goes back to its origin. All of this goes back to one controller, and that controller, we're just watching tolerances around a gauge block calibrated value. This one is an OD, and this is a part length.
How precise can it get?
0.2 of a thousandth on length, and between 0.2 and 0.4, depending on how fast of an indexing machine you have. We're also using our encoder here for our broken tool detector. We have an alarm for going back to its origin, an alarm for chips on the tool, and we also have an alarm for presence of the tool. If any of those go, they set a set of relays to their fault state and can trigger your machine to shut down or part diversion.
Is this the kind of thing where